Hello everyone, my name is Beniz Öncü and these are my friends.
I'm Ayşe Çolak. I'm Ayşenur Kapısız.
Our project is the Optimum implementation of improved successive cancellation polar decoder on FPGA platform. In this video, we are going to try to explain what is our project and benefits of it. Let's start with introduction. We plan to do our polar encoders and decoders by using FPGA digital devices programmed in VHDL programming languages. For this, first of all, before building the hardware, polar encoders and repeated repeats code decoders are simulated in MATLAB. After that, hardware will be built in FPGA environment. Results achieved both from simulation and hardware will be compared. To run the algorithm faster in FPGA environment, we propose to decode many bytes at the same time. The speed gain will be in clock time. The proposed model and classical decoder models will be tested on both double delay channels and IWGN channels. Field programmable gate arrays are semiconductor devices that are based around a matrix of configurable logic blocks connected via programmable interconnects. FPGAs can be programmed to desired applications or functionality requirements after manufacturing. The purpose of our project. One way to increase the speed of the decoder is to decode the bytes not 1 by 1, but 2 by 2 and 3 by 3. It is possible to do this in FPGA environment since the FPGA has the ability to perform parallel operations. We have seen for the successive cancellation decoding that it is necessary to know the previous bit to be able to decode the current bit. However, this is not necessary if two decoders are run in parallel, since the decoding operation will be done without having to know the previous bit by means of accepting the previous bit is 0 and the other one is 1 by one of the decoders. Polar encoding. In the above lines, we have mentioned how to calculate the producer matrix of polar code and how to perform the encoding operation using this matrix. The MATLAB mentioned process initially will be done in the MATLAB environment. The resulting producer matrix will be used for polar coding in the FPGA environment. Polar decoding. Several algorithms have been proposed in the scientific world for the decoding of polar codes. The two most basic of these algorithms are successive cancellation decoding and list decoding. Block diagram. There is a receiver and transmitter. The middle channel is binary arrangement channel. Binary arrangement channel is using the simulation of internet environment. Feature works. The polar encoders and decoders will be performed on the FPGA platform. After performing the successive cancellation decoding algorithm on the FPGA platform, speed gain will be calculated by the implementation of the method suggested in AIM section. In the remaining time of the project, to increase the speed and decrease total clock pulse numbered by the optimizing the hardware implementation and reducing the amount of calculations. New additional methods will be discussed with the project members. This is our FPGA polar code. After our code is finished, we are going to send it to FPGA cards.